Bermuda Triangle has captured imaginations with stories of vanished planes and ships, but now a new scientific theory claims to finally have the answer.
For decades, the Bermuda Triangle has been treated like a joke by some and a genuine mystery by others. Ships gone without a trace, planes that vanished from radar with no wreckage ever found, compasses spinning for no reason, pilots reporting strange fog that swallowed the horizon. Most of these stories get repeated so often that people stop asking whether they're even true. But somewhere in the middle of all the noise, there's a real patch of ocean floor that genuinely confused the people who mapped it. And almost nobody outside of a small circle of researchers ever heard the full story of what their equipment recorded. This is that story, told the way it actually unfolded, without the ghost ship exaggerations and without pretending the questions have been answered, because they haven't. Picture a survey ship sitting quietly on calm water somewhere between Florida, Bermuda, and the northern coast of Cuba. This region isn't some tiny stretch of sea. It spans roughly 500,000 square miles of open ocean, and underneath that surface is a seafloor that has never been fully mapped. Most of what people call exploring the ocean is really just skimming the surface. Even now, we have better maps of the moon than we do of large parts of our own seafloor. And that gap is exactly why a routine survey contract turned into one of the most talked about anomalies in modern underwater exploration. The mission wasn't set up to hunt for mysteries. It was commercial. A private survey team had been contracted to scan a section of seabed for shipwrecks, the kind of job that happens more often than people realize. Companies and governments pay for these surveys hoping to locate old wrecks, sometimes for historical value, sometimes because of rumored cargo. Gold coins, silver bars, colonial-era treasure that sank centuries ago and never resurfaced. The plan was simple on paper. Drag a sonar array behind the ship, scan the bottom and long parallel lines, mark anything unusual, and move on to the next grid square. For the first stretch of the mission, that's exactly what happened. Mud, sand ripples, scattered rock, the kind of seafloor you'd expect anywhere in that part of the Atlantic. Then the sonar operator noticed something on the display that didn't fit the pattern. It wasn't dramatic at first, just a section of the readout that looked slightly too orderly. Natural seafloor tends to be chaotic. Rocks break unevenly. Sediment shifts in random clumps. Coral grows in irregular clusters. What showed up on the screen that day had straight edges. It had corners that looked close to 90 degrees, and the spacing between the shapes looked almost rhythmic, like someone had set them down with a measuring tape instead of leaving them to nature. The operator assumed it was equipment noise. That's the first assumption anyone makes, because false readings happen constantly in underwater surveying. Interference, temperature layers in the water, a loose connection, a miscalibrated sensor. So they did what any careful team would do. They turned the ship around and ran the same line again. The pattern came back exactly the same. They adjusted the gain, which controls how sensitive the sonar is to weak versus strong signals, thinking maybe they were picking up noise that only looked like structure. Same result. They changed the frequency, which changes how deep the sound waves penetrate and how they bounce off different materials. Still the same shapes appeared on the screen. At that point, the easy explanations started running out, and the crew moved on to the detail that actually convinced them something worth investigating was down there: shadows. This part matters more than people realize when they hear about sonar imagery. Sound doesn't behave like light, but it does create something similar to a shadow. When a sound wave hits something tall enough to block the waves from reaching the seafloor behind it, that blocked area shows up as a dark patch with no return signal. Flat ground doesn't produce shadows. Buried objects don't produce shadows, because sediment absorbs the sound gradually rather than blocking it sharply. A true shadow means something is standing up off the bottom, tall enough and hard enough to interrupt the sound waves cleanly. And when the crew looked closely at their readout, there were shadows. Behind every one of those strange rectangular shapes, a dark line extended out at an angle, exactly the way it would if something with real height and a hard edge was sitting on the seafloor. They ran the scan a third time, then a fourth, then a fifth, approaching from different directions and different speeds, so they couldn't blame the angle of the ship or a repeating glitch in the software. Every single pass gave them the same shapes, the same spacing, the same shadows. At some point, A technical malfunction stops being a believable explanation, because malfunctions are rarely this consistent. Whatever was producing that pattern was physically there, sitting on the bottom of the ocean, roughly 2,000 feet below the surface. 2,000 feet is deep enough that almost nothing about it feels casual. Sunlight disappears within the first few hundred feet, and by the time you're anywhere close to that depth, the water is in permanent darkness. Pressure at that depth is enormous, more than 70 times what you feel standing at sea level, which is part of why sending equipment down there is treated so carefully. A cheap camera rig isn't going to survive that kind of pressure, and once something breaks that deep, there's usually no getting it back. So before anyone committed to sending a remotely operated vehicle, an ROV, down to actually look at whatever the sonar was picking up, the team spent real time preparing. Cables were checked for even minor fraying. Seals were pressure tested. Backup power systems were run through failure simulations. Nobody wanted to lose an expensive piece of equipment chasing what might still turn out to be a strange, but ultimately natural rock formation. When the ROV finally went into the water, the first few hundred feet looked completely unremarkable. Small fish drifted past the camera. Sunlight, thin and blue, still reached that shallow. But as the machine kept descending, the light thinned out fast, and within a few hundred more feet, there was nothing left except the beam from the ROV's own floodlights cutting through open water. Anyone who has watched footage like this knows how strange that transition feels. One moment you're looking at something that resembles an ordinary dive video, and the next, you're staring into a completely black frame with nothing but drifting particles catching the light, like snow falling in slow motion through nothing. Then, close to the bottom, shapes started forming at the edge of the light. The ROV pilot slowed the descent. What first looked like ordinary boulders scattered across the mud started resolving into something with far too much geometry to be random. Large, flat-top surfaces set close together, some of them with edges sharp enough that they looked almost machined rather than eroded. In most underwater environments, rock formations wear down slowly through current, chemical erosion, and the accumulation of sediment, which tends to round off edges and blur any original shape over enough time. What the camera picked up instead were surfaces with corners that still looked crisp, arranged with just enough spacing and alignment that more than one person in the control room reportedly assumed at first that they were looking at ruins. That word gets thrown around too easily in stories like this, so it's worth being careful with it. Nobody with real credibility stood up and declared they'd found a lost city. What actually happened was quieter and, honestly, more interesting. Trained researchers looked at footage that didn't cleanly match any of the categories they were used to identifying. It didn't look like a typical rock outcrop. It didn't look like coral growth. It didn't match known patterns of collapsed cliff material or volcanic rock. And it didn't match any charted shipwreck in that location either. The honest answer, the one that doesn't make for a dramatic headline, is that the team had found something they couldn't immediately explain, and that uncertainty is exactly why the footage kept circulating among researchers instead of disappearing. Every serious investigation eventually runs through the boring explanations first, because boring explanations are usually correct, and skipping past them is how bad information spreads. Ocean currents were the first thing considered. Water moving over the seafloor for thousands of years can absolutely reshape rock, but currents scatter material, they don't organize it. If these formations were the product of current erosion alone, you'd expect debris fields, uneven piles, and scattered fragments, not aligned rectangular surfaces with consistent spacing. Volcanic activity was the next candidate, since cooled lava can sometimes fracture into surprisingly geometric shapes, the same process responsible for famous natural formations like basalt columns in other parts of the world. But volcanic fracture patterns tend to be far more irregular at close inspection than what the ROV recorded, and this particular stretch of ocean floor doesn't have a strong geological history of the kind of volcanic activity that produces those effects. The strongest natural candidate turned out to be geological jointing, a slower and less dramatic process where pressure and temperature changes over enormous stretches of time cause rock to fracture along surprisingly straight, repeating lines. It happens on land in a handful of well-documented locations around the world, where cliffs and rock formations look so deliberately shaped that early explorers genuinely mistook them for human construction before geologists figured out the real cause. It's entirely possible that something similar happened underwater in this case, especially given that the regional geology includes limestone, a rock type known for fracturing in structured patterns under the right conditions. The honest problem is that nobody has been able to confirm this explanation either, because confirming it requires something that never actually happened here: physical samples. This is the part of the story that skeptics focus on, and they're not wrong to. No rock samples were ever collected from a site and sent to a lab. No isotope dating was performed to establish how old the material actually is. No drilling was done to see what lies beneath the surface layer or whether the formation continues downward in a way that would suggest either a natural fracture system or something built in layers. Without that kind of direct physical evidence, you're left comparing video footage and sonar readouts against known patterns, which can tell you that something is unusual, but can't tell you definitively what caused it. Extraordinary claims still require extraordinary evidence, and footage alone, however strange it looks, doesn't clear that bar on its own. But dismissing the story entirely isn't quite fair either, and this is where things get genuinely uncomfortable if you sit with it for a minute. If this formation is natural, it's an unusually striking example of geological jointing that just happens to sit in one of the most talked about stretches of ocean on the planet, at a depth that raises its own question. If this area was ever above sea level, when would that have been? And what would that mean for how long humans have occupied coastal regions in this part of the world? Sea levels have shifted dramatically over the last 20,000 years as ice ages ended and glaciers melted, and there are legitimate, well-documented cases of ancient coastal settlements now sitting underwater in other parts of the globe, discovered only because rising seas swallowed land that used to be dry. It's not far-fetched to imagine that parts of the Caribbean seafloor were dry land within a time frame that overlaps with early human activity. Whether this particular formation has anything to do with that is a separate question, one that remains unanswered because nobody has been back down with the equipment needed to actually test it. That's really the uncomfortable center of this story. Not a confirmed lost civilization. Not proof of anything supernatural happening in the Bermuda Triangle. Just a documented, sonar-confirmed, camera-verified formation on the ocean floor that multiple qualified people looked at and couldn't confidently explain. Sitting in a region already soaked in decades of unresolved stories and never fully investigated again after that initial mission ended. The footage exists. The sonar data exists. The shapes, the shadows, and the spacing are all part of the recorded survey, not internet speculation added afterward. What's missing isn't drama, it's follow-up. A return expedition with a budget and mandate to actually collect samples, run dating tests, and settle the question one way or the other. It's worth remembering that the Bermuda Triangle's reputation didn't come out of nowhere either, even if most of the ship and plane stories have far more mundane explanations than people assume. Heavy shipping traffic through a hurricane-prone stretch of ocean produces more wrecks than average simply through exposure. Compass anomalies in parts of the region are tied to one of the few places on Earth where magnetic north and true north nearly align, which can confuse navigators unfamiliar with the correction, not some unexplained force. Most disappearances attributed to the triangle have documented unremarkable causes once you dig into shipping records and weather reports from the time. None of that makes the region less real as a place with genuine hazards, and none of it explains away what showed up on that seafloor survey, because that discovery isn't part of the old folklore. It's a separate, much more recent, and much more physically documented anomaly that happens to sit inside the same general stretch of ocean people already associate with mystery. So where does that leave things? Somewhere between two explanations that both remain incomplete.